In this video, I want to talk about dynamical systems. And to start with, I'm going to give a few definitions related to this. A dynamical system is a finite set of variables whose values change with time. The value of a given variable at a point in time is called the state of the variable at that time. And the vector formed from these states is called the state vector of the dynamical system at that time. So let's start with a basic example. Let's suppose we have two competing TV channels that each have 50% of the viewer market at some initial point in time. Over each 1-year period, Channel 1 captures 10% of Channel 2 shares, and Channel 2 captures 20% of Channel 1 share. So we want to know what is each channel's market share after 1 year. So I can do a picture to represent this system. So this is Channel 1, this is Channel 2. We know that Channel 1 captures 10% of Channel 2 share, so 10% of Channel 2 is going to come over to Channel 1. That means 90% stay at Channel 2. Channel 2 captures 20% of Channel 1 share, which means 80% will stay. So we want to know what happens after 1 year. So let's start by introducing some variables. We'll let x1 of t be the fraction of the market held by Channel 1 at time t, and x2 will be the fraction of the market held by Channel 2 at time t. So what we're going to do is we're actually going to consider this column vector, which has x1 in the first coordinate and x2 in the second. And these variables form a dynamical system whose state at time t is this vector x of t. So for t equal to 0, we know that each share is 50%, so 0.5 in the first coordinate and 0.5 in the second, and this would be x of 0. So let's try to see what happens at time 1, t equal to 1 year later. Well, let's start with Channel 1. They have 80% of their original 50%, plus 10% of the portion that Channel 2 had. And if we work this out, we get 0.45. So after 1 year, they have 45%. Channel 2, after 1 year, has 90% of its own 50%, plus 20% of the original 50 that Channel 1 had, so 0.55. So Channel 2 has 55%. And so with this, we have that x1 would be equal to 0.45, 0.55. What about over a 5-year period? What if I want to see what happens over 5 years? Well, in order to figure this out, let's suppose we know what happened at time t equal to k, and we want to know what happens at k plus 1. So we know x1k and x2k, and then we want x1k plus 1 and x2k plus 2. What happens 1 year later? Or k plus 1. What happens 1 year later? Well, the analysis is exactly the same that we did before. x1 k plus 1 is equal to 80% of Channel 1's original share, plus 10% of what Channel 2 has. And x2, well, they will have 20% of Channel 1 that will move over, and they will hold 90% of their share. And this can actually be expressed in a matrix. x1k plus 1, x2k plus 2, or k plus 1. This is the matrix given by 0.8, 0.1, 0.2, 0.9, times x1 of k, x2 of k. So we can use matrix multiplication to compute the state of a system at a given time. So we can use this to calculate further time periods. So for instance, if I wanted to find what happens after 2 years, I would multiply this matrix times the result that we got for 1 year, which was 0.45, 0.55. And if we do, we would get 0.415 and 0.585. For x3, I would multiply this matrix by 0.415, 0.585. I won't show the steps, but we would get 0.3905 and 0.6095. Multiplying the matrix by this vector, by x3, would give us x4, which is 0.37335 and 0.62665. And then finally, multiplying the matrix by x4 would give me x5, which was 0.361345 and 0.638655. So after 5 years, channel 1 will hold about 36% of the market, channel 2 will hold about 64% of the market. And we can continue this process more and more.